There's a moment when a technology stops being a concept and starts being inevitable. Most people miss it. They're looking at the wrong thing, asking the wrong questions, measuring the wrong numbers. Right now, in 2026, something is happening inside Tesla's facilities that doesn't quite look ready yet. And that's exactly why you should be paying attention. Because the things that change everything rarely look impressive at the start. Tesla's Optimus robot can sweep a floor. It can stir food, open cabinets, close curtains, grip an egg without cracking it. It served water bottles at an event in Austin, Texas in March of 2026. And if that sounds underwhelming to you, good. That reaction is precisely what this video is about. Because the people who saw the first grainy footage of a self-driving car prototype probably thought the same thing. And now autonomous vehicles are rewriting insurance law, urban planning, and trillion-dollar logistics networks. What you are watching with Optimus is not a product launch. It is a civilization-scale infrastructure project in its earliest, most awkward phase. Let's start with what is actually true, because the honest picture is more interesting than the hype. In January of 2026, Elon Musk admitted something that most Tesla bulls quietly ignored. Zero Optimus robots were doing useful work inside Tesla factories in any material way. The program was still, in his own words, very much in the early stages, still in research and development. He had previously claimed that several thousand robots would be performing factory tasks by the end of 2025. That did not happen. He had said the program would produce 10,000 units in 2025. That did not happen either. And before that, in mid-2024, he said 2 Optimus robots were autonomously performing tasks on the factory floor. Analysts found no evidence to support that claim. So if you are keeping score on Elon Musk's timelines, the record is not good. But here is where most coverage gets it wrong. They stop at the scorecard. They count the missed deadlines and declare the program a failure, or at best, a PR exercise. And in doing so, they completely miss what is being built underneath the surface. Look at the hardware. The third-generation Optimus hand has 22 degrees of freedom, up from 11 in the previous version. It uses a tendon-driven system where 25 actuators are packed into the forearm, mimicking the biomechanical architecture of an actual human hand. The fingertip sensors detect force in real time, allowing the robot to hold an egg, thread a cable, or pick up a glass of water without crushing it. The precision tolerance on these hands reaches 0.08 millimeters. A human hair is roughly 70 micrometers thick. That number is not a party trick. It is an engineering statement about what kinds of tasks this system will eventually be capable of performing. And then there is the software architecture. Tesla is not programming Optimus with traditional robotics code where every movement is scripted in advance. They are training a single neural network on first-person video footage of humans performing tasks. The robot watches, learns the underlying structure of the motion, and builds its own internal model of how to replicate it. The dance routine that Optimus performed without a tether in May of 2025 was trained entirely inside a simulation. The robot never physically practiced it. It learned in a virtual world and executed in the real one. That pipeline from simulation to physical reality is one of the most important technical capabilities in robotics today. And Tesla, because of its decade of work on autonomous vehicle AI, already had the infrastructure to build it. This is the thing most people are missing. Tesla is not a car company that decided to build a robot. Tesla is an artificial intelligence company that happens to manufacture vehicles and has spent years developing the exact computational systems that humanoid robotics requires. The sensor fusion, the real-time decision-making, the neural network training pipelines, the simulation environments, all of it already existed. Optimus is not Tesla's first step into AI. It is the physical embodiment of AI systems Tesla has been refining since 2015. Now consider the manufacturing dimension. Tesla has built some of the most efficient high-volume production facilities on Earth. The Gigafactory in Austin, Texas, covers an area equivalent to roughly 150 football fields. Tesla has already solved problems that would take most robotics startups a decade to even encounter. Problems around supply chain integration, component sourcing at scale, assembly line optimization, and vertical control over critical parts. When Tesla says it wants to eventually produce 1 million Optimus robots per year, the instinct is to laugh. But Tesla also said it would produce 500,000 cars per year, and then it did, and then it exceeded that. The company's ability to translate ambition into industrial capacity is, historically, more reliable than its ability to hit a specific date. Here is the number that should make you pause. Tesla's target price for Optimus is between $20,000 and $30,000. The closest competitor with comparable capability, Boston Dynamics Atlas, costs somewhere between $150,000 and $320,000. Figure AI's robots operate in a similar premium range. If Tesla can produce a humanoid robot at the price point of a used car, the addressable market does not grow incrementally. It explodes. Every warehouse, every logistics hub, every manufacturing floor that cannot afford a $150,000 robot suddenly has a viable option. That is not a product advantage. That is a category redefinition. And speaking of competitors, the landscape is more complex than most American coverage acknowledges. Chinese companies are not waiting. In 2025, Agibot shipped roughly 5,100 units globally, generating around $140 million in revenue. Unitree's G1 robot is already being mass-produced. UB Tech has active commercial deployments. Chinese manufacturers accounted for more than 80% of all humanoid robot installations in 2025. That is not a footnote. That is a geopolitical signal. The country that wins the humanoid robotics race does not just win a product category. It wins the ability to manufacture everything else faster, cheaper, and with fewer human labor constraints than any competitor on Earth. Figure AI, an American company, live-streamed their robot sorting 12,700 packages in 10 hours, operating continuously for nearly a week. That happened. That is not a demo. That is deployment. Boston Dynamics' new electric Atlas was declared production-ready at CES in 2026, with units already deployed to Hyundai facilities and in collaboration with Google DeepMind. So where does Tesla actually stand? Honestly, behind in deployment, but potentially ahead in the variables that determine long-term dominance. The AI training infrastructure, the manufacturing cost architecture, the vertical integration across batteries, actuators, and software. None of Tesla's competitors control all of those simultaneously. Most of them are buying components from suppliers, building software on top of third-party hardware, and hoping the unit economics work out. Tesla is building the entire stack. But let's be serious about the limitations, because they are real and they are significant. Battery life on current Optimus units runs between 2 and 4 hours under industrial workloads. A human worker operates for 8. That gap is not closing quickly. The dexterity ceiling, while improving rapidly, still falls short of human productivity on complex assembly tasks. Safety certification for unsupervised operation in fenceless environments, meaning spaces where humans are present, has not been achieved. And the fundamental credibility problem that comes with Musk's repeated timeline failures creates a fog of uncertainty that makes it genuinely difficult to assess where the program really is versus where Tesla says it is. Expert analysis firms offer a sobering counterpoint. Interact Analysis projected in mid-2025 that the global humanoid market would reach only 40,000 units by 2032, generating around $2 billion in revenue. That is a far cry from the multi-trillion-dollar civilization transformation that Musk describes. Bain and Company noted that most humanoids remain stuck in pilot programs, heavily dependent on human supervision. The gap between controlled demo and actual industrial deployment is proving wider than the industry expected. And yet there is something in the trajectory that deserves honest acknowledgement. The speed at which Optimus has developed from a concept in 2021 to hardware capable of 0.08mm precision dexterity in early 2026 is genuinely faster than most robotics researchers expected. The integration of simulation to reality AI training is a real breakthrough. The manufacturing cost ambition, if even partially achieved, would be genuinely disruptive. The question is not whether humanoid robots will transform labor and manufacturing. Most serious analysts believe that transition is inevitable. The question is who gets there, when, and at what scale. Here is what I want you to sit with as this video ends. We are almost certainly in the awkward, unglamorous, easily dismissed early phase of something that will eventually be obvious in hindsight. The historians of 2040 or 2050 will probably look back at this exact moment, when a robot served water bottles in Austin and couldn't yet hold down a shift on a factory floor, and they will identify it as the beginning. The same way we look back at a grainy video of an early iPhone and think, of course, that was the moment everything changed. The robots are not ready. The infrastructure is not ready. The economics are not fully proven. And none of that changes the underlying trajectory of where this is going. So here is the question I want to leave in your mind. If Tesla manages to produce a humanoid robot at the price of a used car within the next 5 years, what happens to the economics of every industry that runs on human physical labor? Not just manufacturing, warehousing, agriculture, construction, elderly care. Every sector where the cost of a human body is the dominant cost structure. Think about that, because that question is not science fiction anymore. It is an engineering problem with a funded team working on it every day. If you want to keep watching what is actually happening beneath the surface of the next industrial revolution, not the headlines, not the hype, not the quarterly earnings spin, but the real structural shifts that will define what your economy looks like in 20 years, subscribe. Because this is the kind of story we are here to tell. And it is just getting started.